Good day! So yung topic natin ngayon ay differential equations or ordinary differential equations. Maraming types ng differential equations but we'll focus mainly dun sa separable differential equations. So what is a differential equation? It is an equation na may laman na isang unknown function or one or more of its derivatives. O pwede rin yung derivatives lang niya, yung meron sa kanya. So an example of a differential equation would be this one, dy over dx is equal to x cubed over y squared. And another example will be y double prime is equal to 7x minus 2. Ang order ng isang differential equation ay yung order ng highest derivative sa kanya. So in our first example, ang order niya ay 1 or first order differential equation siya. Yung second example natin, yung y double prime equals 7x minus 2, this is a second order differential equation or meron siyang order 2 kasi hanggang second derivative yung meron tayo sa equation. Sinasabi natin na ang isang function, let's say f of x, ay yung solution ng differential equation kung masasatisfy niya yung differential equation by substituting y equals f of x pati dun sa mga derivatives niya. At pag nagsosolve tayo ng differential equation, hinahanap natin lahat ng possible solutions ng isang differential equation. Na maraming types ng differential equations, pero sabi natin magfo-focus tayo sa separable. So sinasabi nating separable ang isang differential equation pag yung derivative ay pwedeng i-express as a product or quotient ng isang function of x at isang function of y. So pwedeng we have here dy is equal to f of x times g of y. Or pwede rin kung ililet natin si h of y be equal to the reciprocal of g of y na dy over dx or the derivative of y is equal to f of x over h of y. So we could express yung function of x at yung function of y as factors at pwede natin silang paghiwalayin like so na imumultiply natin to both sides si h of y. At the same time, si dx imumultiply din natin sa both sides para magkaroon tayo ng expression na h of y dy is equal to f of x dx. And this allows us to take the integral of both sides, so we'll get the integral of h of y dy is equal to the integral of f of x dx. In the hope that if we evaluate the integral, makakakuha tayo ng expression for y. Now let's take a look at some examples. For our first example, hanapin natin yung general solution for dy over dx equals x cubed over y squared. What do we mean when we say general solution? So meaning, ito yung lahat ng possible na functions na pwede nating isubstitute sa y para pag kinuha natin yung derivative niya, we will get that the derivative of y with respect to x is equal to x cubed over y squared. So lahat ng functions. We can see that this is a separable differential equation kasi yung derivative, si x cubed over y squared, pwede natin express na factor or product or quotient ng isang function of x at isang function of y. So we could separate it like so. Sulat natin siya as y squared times dy is equal to x cubed times dx. We take the integral of both sides. So on the left, makukuha natin na y cubed over 3. Tapos equal siya sa kanan na x to the fourth over 4 plus c. Now, bakit yung plus c nasa isang side lang? Eh di ba dapat pareho silang may plus c? Well, kung anumang constant yung lalabas sa kaliwa, pwede mo na siyang isama dun sa constant na lalabas sa kanan para isang constant na lang yung dinidil natin. Multiplying both sides by 3, we'll get y cubed is equal to 3 over 4 times x to the fourth plus 3c, or y cubed is equal to the cube root of the quantity 3 over 4 times x to the fourth plus 3 times c. And we could box this as our final answer. Now, let's take note na yung 3 times c, well, constant din naman yan. So, wala namang masama kung palitan na lang natin siya ng isang buong constant like gawin natin plus k. It's also a correct answer. Now, let's check our solutions. Kasi meron tayong function eh. So, we could take the derivative of this function. So, y is equal to 3 over 4 times x to the fourth plus k. Raise na lang natin to 1/3 instead of taking the cube root. Pareho lang naman yun. The derivative of y is equal to, baba natin yung 1/3. 1/3 times, so gagamit tayong chain rule, times 3 over 4 times x to the fourth plus k raised to 1/3 minus 1 or negative 2/3 times the derivative of the inner function, which is 3x cubed. We could already cancel dito yung 1/3 tsaka yung 3 sa 3x cubed. And we'll get that this is equal to x cubed Then yung naka-raise to negative 2/3, pwede nating ilagay sa baba. Isulat natin siya na 3/4 times x to the 4th plus k raised to 1/3 squared. Paghiwalayin natin. And notice, ano ba yung nasa loob ng square brackets? That is exactly equal to y. So, substituting y, we'll get that y prime is equal to x cubed over y squared. And this verifies our solution. Now, notice yung ating solution ay may plus k. Ito yung mga possible na maging graphs nung function natin depende sa value ni k. So we could see here that we'll have an infinite number of solutions for this problem, and by using a constant, we are essentially covering all the possible solutions of our differential equation. Kaya siya general. Parang it's a family of functions na magsasatisfy nung ating differential equation. Let's move on to our second example. We want to find the complete solution for d squared y over dx squared is equal to 2x minus 7. Gumamit lang ako ng ibang wording, pero when we say complete solution, pareho lang siya sa general solution. And notice that this is a second order differential equation kasi nasa second derivative yung derivative natin sa differential equation, no? And let's take note na ang y prime, that's equal to dy over dx. And si d squared y over dx squared equal siya sa derivative ni dy over dx or dy prime over dx. Okay? So we'll first solve for y prime. So yung ating differential equation, isulat natin na dy prime over dx equals 2x minus 7. Separate natin yung dy prime sa dx and write it as dy prime is equal to 2x minus 7 times dx. Then let's take the integral of both sides and we'll get that y prime is equal to x squared minus 7x plus a constant. Let's call that constant c1. Now y prime is dy over dx. So i-rewrite natin yung equation as dy over dx equals x squared minus 7x plus c1. Again, this is a separable differential equation. I-separate natin si dy and dx. And write it na dy is equal to the quantity x squared minus 7x plus c1 times dx. Let's take the integral of both sides and we'll get our function na y is equal to x cubed over 3 minus 7x squared over 2 plus c1 times x plus c2. So meron tayong dalawang constant, c1 and c2, and again, we'll have an infinite number of solutions for this differential equation. For our third example, mag-try naman tayo ng konting trigonometric functions. We want to find the general or complete solution for d squared u over dv squared is equal to tangent v times secant squared v. We could write it as the derivative of u prime. So du prime over dv is equal to tangent v times secant squared v. Separate natin si du prime at dv. Du prime is equal to tangent v times secant squared v times dv. We'll take the integral of both sides. Kung naalala nyo yung integral niya, great. Kung hindi, gamit tayo ng substitution. Since we're using u and v, edi we let x be equal to secant v. So dx is equal to secant v tangent v dv. So the integral of du prime is u prime. This is equal to, applying the substitution, the integral of x times dx, which is equal to x squared over 2 plus c1. Pero u prime pa lang to, which is the same as du over dv. Back substituting, we'll get that du over dv is equal to secant squared v over 2 plus c1. Separating again si du over dv, we'll get du is equal to secant squared v over 2 plus c1 times dv. Taking the integral of both sides, we'll get u is equal to 1/2 times the antiderivative of secant squared, so tangent v plus c1 times v plus c2. And again, we'll have a general solution na meron dalawang constants. So again, there's an infinite number of functions that will satisfy this differential equation. For our last example, so bakit natin ini-specify na may general or complete? Kasi we can talk about a particular solution. So di ba may infinite number of functions, pwedeng isa lang dun sa infinite number of functions yung gusto nating sagot. So here, we want to look at yung second example natin, si d squared y over dx squared equals 2x minus 7. Pero ang hinahanap natin ay yung particular solution na y is equal to 55 over 6 and y prime is equal to 0 pag x is equal to -1. So out of those infinite na functions, alin doon pag x is equal to -1 will give us y prime equals 0 and y is equal to 55/6. So tandaan natin na na-solve na natin yung general solution for this. Y is equal to x cubed over 3 minus 7x squared plus c1x plus c2. This is the complete solution. And that the first derivative of y or y prime is equal to x squared minus 7x plus c1. At x equals -1, sabi sa atin y prime is equal to 0. So substituting x equals -1, we'll get 0 is equal to -1 squared minus 7 times -1 plus c1. Then this will give us that c1 is equal to -8. So solve na lang natin si c2. Yung next na information na binigay is that the function y is equal to 55/6 if x is equal to -1. So substituting, we'll get 55/6 is equal to -1 cubed over 3 minus 7 times -1 squared over 2 minus 8 times -1 plus c2. And 55/6 is equal to 25/6 plus c2, giving us c2 is equal to 5. So nahanap na natin yung dalawang constants. Our particular solution is f of x is equal to x cubed over 3 minus 7x squared over 2 minus 8x plus 5. Out of all the infinite possible solutions of our differential equation, ito lang yung magsasatisfy nung conditions na sinet for this problem. So on our next video, we'll take a look at more examples. And for now, salamat sa pakikinig.